Welcome, everyone. We're really excited to bring you the information about version 3.2, which we launched last week, exactly a week ago today, at Graph Connect London. What I want to do as I go through this presentation is we'll talk a little bit about the setup for this release, and then we'll discuss the specific features. But of course, as we look back at all of the capabilities and sort of firsts that we've been able to deliver over the years, what I think makes this particular release so interesting is its core feature is multi-data center support for global applications. Now, as we look at it, let's do that review very quickly of version 3.1, which we announced in October and delivered in October. And there were two primary elements that we delivered there. One was the introduction of the new causal clustering architecture, and then the delivery of core security features for the enterprise, specifically support for users and roles inside the database, as well as integration with LDAP directories. So when we look at the causal clustering architecture, this is becoming very, very popular. It's a RAF-based architecture that accepts writes to the core servers. Those are the blue guys here. And within that, they develop a consensus as to when to accept a transaction and when to reject it. So in this case, 2 out of the 3 read-write servers there would accept a transaction and then make sure that everybody gets caught up based on that raft design. Read replicas, therefore, can be delivered in any number of formats or any number of particular roles. Perhaps an application that's delivering real-time information that would be driven by or fed by a read replica, and at the same time, perhaps also feed a read replica for reporting and analytics or backups, things like that. When we delivered this, we also introduced the Bolt driver and for the server themselves. And as you'll see in a minute, the drivers have become even more and more intelligent about how the routing exercises happen inside of the cluster. And the benefit of that, of course, is that the developers of Neo4j based applications don't need to know about the particulars of, they don't have to put into the application themselves rules about routing, rules about load balancing, rules about what the particular roles are of a server member. So this causal clustering architecture, of course, continues our support for ACID-based consistency and transactions. We believe that that's very, very important in terms of maintaining the integrity of your data. And the system originally, as it was designed and delivered, supports the concept of reading your own writes. So the application itself always sees a consistent view of the database itself and what the application is expecting of the database if it happens to have added a transaction to the system. And this particular architecture is horizontally scalable in a number of different ways, and can support thousands of cluster members in this design. So, summarizing it, the resilient, modern, fault-tolerant kind of architecture delivered in causal clustering is really where we were and are steering customers who have high availability and scaling desires. The other major elements of 3.1 were, as I just said, were the security foundation that we had laid down. And our intention is to support strict regulatory environments, strict data governance style environments where IT has to make sure that particular perhaps data lineage, perhaps different data values is enforced as they're adding or installing Neo4j. So within the 3.1 release, we delivered a number of user-based security capabilities, including the support for both Active Directory and Open LDAP, or supporting our own user-based user system internally within the database. We also have role-based authorization, the ability to monitor queries on a user-by-user basis, and overall access controls for user-defined procedures, which in turn can be used to get to even property level or node level security on a particular data element on a user-by-user or role-by-role basis. So what I wanted to do is just lay that out, because that's sort of the foundation from which we're building as we introduce version 3.2. So in 3.2, the themes that we're tackling here are continued investment in the scalability of the environment. In this case, support for multi-data centers and multi-data center awareness for these global applications that we think we're delivering. Continued investment in the governance capabilities for the connected enterprise, quote unquote, as well as this is our continuing drive to make Neo4j the most performant native graph database on the market. So you'll see a number of very cool elements here that we've added to improve performance. So as I said, the biggest feature, or the headline feature for this particular release is data center awareness. Now causal clusters can span different data centers. They can be global, and when you set this up, we deliver a high degree of flexibility in how you might want to configure these particular servers, whether that's having a centralized core in a single data center or a centralized core spread across data centers. That original causal clustering architecture with consensus-based transactionality is still maintained even across these different data centers. And you see here, I've got data centers that I'm showing in both New York as well as London, and some other clever things that we've inserted in here are things like the ability for when we're delivering the read replica updates, we can do so on a hierarchical basis and assign where a particular replica receives their updates, whether that's a local replica or a local core, or it can be a core across delivered across the network. You now have that kind of flexibility built in, and it really, as we go forward in this, we'll have a couple of examples of why this is important, and continues the idea of supporting the read your own rights capability. So these tiered subclusters allow you to maintain really high degrees of performance locally, very much the same way, the same attention that perhaps Netflix does for delivering movies, right? Get the content as close to the edge of the internet as possible in the most efficient way for that particular application, so you deliver very, very high degrees of performance to the application, while also minimizing the amount of wide area network traffic that we're creating. So this topology-aware stack allows also allows the bolt drivers, the drivers of the application, to maintain all of this logic about where cluster groups live and what their configuration is, what their fallback positions are when you're in a high availability case. All of that kind of functionality is built into the driver, again, so the developer of a Neo4j application doesn't need to worry about where they're deploying the application while they're developing it. That deployment, that separation between the foundation of the application and then the topology upon which it's going to be delivered is deliberate here. And then there's a couple of other interesting things. We've added some cloud delivery options to our scheme. So now you can Neo4j is available in the Azure cloud from Microsoft, as well as the Amazon EC2 cloud. So this data center awareness and support for these global applications, you can really get a good sense here of the way in which we're creating and delivering this environment. You can have your different groups spread across the globe, and each particular cluster in a data center can operate as both cores or replicas, as I mentioned earlier. So when you look at that hierarchical update, and maybe I'll go backwards again and illustrate how that works. Cores themselves can be located in a single data center, as I mentioned, or can be located in across data centers. And when an update is delivered, you'll see that I'm only delivering one update to the read replica in New York, and then the local replica copies in that New York data center are receiving their updates from a parent replica. So this hierarchical delivery really allows us to scale that environment most effectively while also minimizing the amount of overall traffic that's getting created. And in the case of supporting both reads and writes in the environment, if I've got a reader who's looking at a read replica, that can occur at the closest or most available replica. You'll recall that the bolt drivers also are supporting all of the load balancing logic that is built into the environment, which you also have control over. So if this particular read replica is not available, it would default to another replica in the local cluster, or it could default to a replica in a different data center. And then when I perform writes, they are delivered first to the local core server, the leader of the cluster, and the leader of the core, and then those updates are propagated across all of the core servers. And this still maintains that consensus-based raft architecture, so that a transaction isn't accepted until, in this particular diagram, 3 out of my 5 core servers accept the update and have committed it to themselves. Then the replication happens across for every other server member and the replicas themselves. So the cool thing about this, when we're supporting the read your own write capability, is even if one of the writers to the database themselves, they'll write to a core, but perhaps the database from which they're reading is more locally available. It's closer to them. So in this particular case, the writes themselves will be delivered back to that replica before that particular application element ends up receiving the results of their subsequent queries, the read activity after they've written the core. So we're maintaining that same ACID transaction capability and making sure that there's a degree of consistency for any local application, that they get the information that they're expecting. So those are, that's the big brand or the headline feature for the release as we're looking at it. Now let's talk a little bit about some of the enterprise governance capabilities that we've added to the environment. The first one here, node keys. This is a brand new schema constraint, and what it's really designed to do is for organizations, when they're either creating an instance of Neo4j or when they're regularly updating it from perhaps other systems in the environment, node keys allows you to set particular constraints on a data element, like existence. This has to have a value, or uniqueness. This has to have a unique value. And the cool thing about this is it allows us to play nicely, let's say, within a highly governed environment. So it's tied to particular labels within the graph, and you can have any number of node keys defined against a node, any number of properties, etc. And this makes sure that, again, it enforces existence and uniqueness and keeps whatever data exchange activities consistent, from data source to data source. Another capability on the governance side that is also in support of our ongoing work in security is we now support and offer a Kerberos module for encrypted authentication. This is an add-on to the Enterprise Edition, and it allows us to support what we'll characterize as a 3-tier integration of the user client, whatever directory you happen to be using in the database itself. So for organizations who are operating in very strict security environments like financial services or healthcare or pharma, the Kerberos module will be very, very popular. We've also introduced causal clustering now on the CAPI flash hardware from IBM, those Power 8 servers. That's also an additional add-on here for the Enterprise Edition. So when you have a very, very large graph and you need the the horsepower and the memory behind a Power 8 system. That's now available. And we offer significantly better metrics in the query monitor. For example, now a user on that user-by-user based query monitoring activity, the user can not only see that their query is running and how much time it's taking, but they can see how much it's hitting against cache versus how much it's hitting against disk. They can see what other elements that the execution time, when it started, etc. So it gives them more detail about what's happening with a query, so they can decide what to do with it. And finally, on our graph performance capabilities and improvements here, the big one that we've introduced is we've taken to redoing the label index so that write speed is dramatically improved. What this means is we wrote our own indexing scheme for the label index so that we could indeed control the behavior of a write or an update to the database. And what we're seeing in typical situations is, let's say, about a 30% improvement in performance there. But in particular, in other cases, we've seen as much as a 300% or 3x performance improvement in that particular activity. For reading, we've also introduced a capability that's akin to the node keys, is composite indexes. In order to improve the performance of read activities. And what we saw here was customers and users would create their own almost handmade or custom properties that would operate in a similar fashion to a composite index. They just assemble themselves by concatenating other properties together. So recognizing that, we decided to add in this composite index capability. Number 3 bullet here is pretty interesting in that we're now, because we own the overall native graph stack, we're able to invest in and modify all kinds of different areas in the database and continuously improve performance of specific activities. So within the Cypher query optimizer, we've taken the depth query in the distinct function. A depth query determines how many levels deep we go into the graph whenever we're looking for information, and we've optimized this so that it doesn't go and retraverse nodes that it already knows or it's already passed over. So this dramatically eliminates repetitive activities that we were performing in earlier versions to only touch a node once and then move forward from that particular node as the depth query increases. So if you have a really deep query right now that's looking anywhere from 5 to 35 levels deep, you're going to notice a really dramatic improvement in performance there. We're also introducing a compiled Cypher runtime in Enterprise Edition, and this is right now supports a small number of the query operations that are arguably the most common operations that a user would perform in Cypher, but it compiles that to deliver a really snappy or speedy response to those basic activities. And then we're laying the groundwork or the foundation here for additional investments in the compiled runtime, as you'll see in the future. Kind of a housekeeping activity is we now have removed the rules-based optimizer in the Cypher in the query optimizers and gone exclusively with the cost-based optimizer because it's always faster than the rules-based one. So we have a lot of confidence now in the cost-based optimization activities, and do recall that operates against. Sorry, lost my train of thought. Anyway, cost-based optimizer is now the default. And finally here, we've rewritten the Neo4j browser to include a more flexible JavaScript framework. So you'll see now that the browser itself should be quicker. We're calling it snappier, just as you're using it on a day-to-day basis. and it gives us a foundation for making improvements more rapidly to the browser itself. And to that end, we added a couple of new things to the browser, which are kind of examples of this rewrite and some of the cool things we're now able to do. So you get syntax highlighting inside the browser. So if you look at the Cypher code at the top edge of that screenshot, we're highlighting and color coding each of the elements inside of that query, and you get auto-completion in this. So now it will help auto-complete things like relationships and labels and properties and other variables. So this makes the activity of typing out Cypher queries significantly easier, improves your accuracy, removes the overall number of keystrokes that you have to navigate through, and really I think just improves the professionality of the Neo4j browser in creating queries. And as you can see, the autocomplete here as well for specific commands inside the browser. So really excited about that. We've actually, where we came out with the headline being the multi-data center capabilities, we've actually had other articles coming out with the new Cypher editor as a flagship capability for developers themselves. So quickly summarizing the feature set on an edition by edition basis. In 3.2 Community Edition, you get the composite indexes and the native label index functionality. You get the improvements to the Cypher query optimizer and the new Neo4j browser. The driver packs themselves have been updated to version 1.3, so transaction handling is now available inside the driver. Again, the developer doesn't need to know about how transactions are going to be handled within the application itself. They can leave that to the driver, and then cluster management and routing decisions is also inside the drivers. And then on the deployment tools, RPM packages as returned as an option. It went on vacation for a release, and cloud delivery that I mentioned earlier. So then, and then building on top of that, the Enterprise Edition adds the multi-data center support, the Causal Clustering API. We've not only are we controlling that transactionality and those routing instructions, but we're exposing an API here within the Bolt drivers, so you can both examine that and programmatically inform what those instructions are supposed to be doing. The compiled Cypher runtime is an Enterprise Edition activity, and overall we feel like that just gives us better control over what we can add in, and then decide on how far to go with putting that back into Community Edition. Node keys for governance, new clever query monitoring capabilities, as I just mentioned, the Kerberos add-on module, as well as the CappyFlash add-on module. So there you are, kind of short and sweet for this particular update, but those are the key highlights for the 3.2 release. Overall, supporting better scale, supporting more enterprise governance kinds of capabilities, and continuous improvement in performance as a whole.